All right, we need to take a look at some zoning or zone valve priority control strategies to expand on our controls of hydronic systems related to whether you're handling priority zones and non-priority zones. So first thing I'd like to address is what exactly is a priority zone? And the term priority is a term that we give, preferential, it's the first in line to be able to get a demand as an example. So for example, I'll give you a couple of examples of priority zones. So by far the most common example of a priority zone would be the fact if we were to use domestic hot water. So if we had a domestic water system that when we need a demand for hot water, we will then disable other types of zones that, as opposed to trying to satisfy everybody's zone demand at the same time. It allows me to then utilize the full output of my heat source or my boiler system to provide the heat to make the hot water, to satisfy that demand. And then after that demand is satisfied, after a certain amount of time, then we'll say, okay, now we're gonna go back and try to finish heating up the zones as we need to. So that's typical. So when we talk about priority and non-priority zones, that's really the most common. You certainly could have other types of priority zones, but that is by far the most, I would say the biggest example or the most common example of a domestic water system. Somebody might use, let's say they may choose to do an ice melt as a priority zone. It's really whatever the system designer feels it's appropriate. And then for us as the techs that come in and have to wire it in circuit, we just have to recognize what was their function, what did they want to do. So that's primarily how we do this. Specifically, what I want to do is look at this figure 946 from the Modern Hydronic Heating textbook. And in this particular one, what I want to identify is in this strategy is this is essentially what we call a system where if we basically give a demand to the domestic water tank, and we're going to hit this one up. So if this thermostat says the water's cold, we need to heat it up, what it will then do is it will then take the 24 volts in this example, running it through this system to energize a relay, what we're going to call R1. Now this priority system is actually doing zoning with pumps. Now why this one has to be done this way or is done this way is this application, we have a thermostat, we energize the 24 volt relay. That 24 volt relay on R1 will take the normally open set of contacts up into the top, it'll close that set of contacts and then deliver hot water or deliver 120 volts directly to the circulator pump that would then be powering the pump that is its responsibility is to provide hot water to the domestic hot water heater. And that's going to pull boiler water out of the boiler system, run it through the heat exchanger, and that pump is going to be used for that purpose. Now, how does this priority work? The way the priority will work in this example is when we take the 24 volts down in this circuit, there is a second set of contacts. So we are going to use, what we're showing is the R1-2 normally open set of contacts. R1-1 open set of contacts is going to close. That will then open the R1-2 normally closed set of contacts in this. Now this would have to be using a separate set of contacts because of the two different voltages. So this particular set of contacts would have to be its own separate set of contacts. So this is going to be the 120 volt side of things. This one here is going to be the 24 volt side of the contact. So that's why we're identifying this one as R1-2, the second set of contacts that is not in the same pole as this particular application. So domestic hot water heats, we satisfy that zone. Now what happens? So whether or not there was a demand, so if there was a demand from R1-2, or if the R1-2, if the domestic water was satisfied, any one of these thermostats, whether it's T1, T2, or T2, T3, or T4, any one of those three, if any one or all of them call, in every situation, they will then energize the respective R2, R3, or R4 relay. It'll energize those specific relays and complete the circuit on the 24-volt side of things. Now, what happens up on top is the switching mechanism in each of these relays will close, close, and close to provide that. Now, the assumption or the expectation is based on the wiring here is that if there is that demand by all of those, by the non-priority zones as well as a priority zones, the non-priority zones are not going to be allowed to function. The priority zone would have to have its zone demand satisfied. So until that happens, this relay is going to disable all the other zones from functioning. So let's assume that the domestic water tank is up to temperature. This opens this circuit. Now what that's going to do is take away power and remove the power from the R1 relay. That will then in turn open that set of contacts, and of course we will not be delivering the 120 volts to that pump anymore. Immediately what will happen is R2, R3, and R4 will now be allowed to close. If any or all of them have a demand, you'll have each one of those respectively will be energizing its own set of contacts, whether it's R2, R3, or R4. They will then, of course, energize P2, P3, or P4 zone space heating. And that is the typical way that a system like that would be used in there. Now, there's one little dilemma that we're going to run into here in this ladder diagram, is that we don't really have any provision to, well, what happens if there's a problem with this domestic water tank system and maybe that's a demand that's unrealistic. That's a little bit of a problem in this case because we don't really have any time limitation that says, hey, if this is calling for too long of a period, this is going to be a problem. So this is something that you have to be aware of, that this could be a problem in this diagram, that there is really in this diagram no provision for what I'm going to call a timeout feature, if that makes sense. So no way, so if the demand is still there, those other zones are not going to be functioning. So in the handout here, I put on here that as a note, this system diagram does not offer a specified time period where the non-priority zones would be allowed to go back to its normal operation until that priority zone demand is completed. And that is going to be a problem in some cases. So I would probably, I would say maybe this is not the best strategy to do this. So there are ways that we can put that in there. So let's take a look at another function. And this was in that. So let's go ahead and put a timeout or a time limiting function. So what we're going to do in this situation is it's the identical diagram to the previous application, except now we're going to add a time delay relay up in the top of our system. So you'll notice that once we get this system energized, so once this system has a demand, so I'm going to go back down in here. So let's say that this is closed. This is now going to be energized at 24 volts. We're going to now take the 24, send it through the thermostat, energize the relay. When R1 becomes energized, that will then in turn open this set of contacts, is what's going to happen. And the 120 volt relay that is up on R1-1 will close. We are going to then send our 120 volt power directly down through R1-1 all the way to the domestic water pump to energize the domestic hot water circular priority load. Once that circuit becomes energized, then the time delay relay now becomes part of the circuit. So we are energizing simultaneously the circulator as well as the time delay relay. Once the time delay relay, whatever that function is, or what, it could be that you might set it up for a 1 hour time period or maybe it's a 30-minute time period. It's really rare that you would ever have a domestic water demand that could take that long. So I think this is really just kind of a safety feature that in the event that we have a problem where that demand just isn't being satisfied for whatever reason, you have an out is the way that works. Now, then of course, once, let's say if this demand lasted for longer than an hour as an example, what will happen then is after the 1 hour period, so let's just say this, after approximately a 1 hour period, what we're going to do now is we're going to take this in the lower part of the 24 volt side of the relay, we're going to then close this set of contacts. Now what I will tell you is that then in turn does not care what this relay R1-2 is doing. So that particular TD1 set of contacts are now going to close, and that will then allow the low voltage side of our circuit to now take power and allow that to go through the circuit, and essentially in parallel with R1-2, we're going to now feed T1 or T2, T3, T4, and so on and so forth. All of these other circuits are now going to be allowed to function if they want heat. So if any one of these wants heat, they can respectively energize the R2, 3, or 4. And of course, once that happens, as we can imagine, that means R2, R3, and R4 would close, provided there was a demand for P2, P3, or P4 space heating. So that would mean T2, T3, or T4. Any one or all of them can have the demand, and then they would energize the respective relays, however that is. It's really a very simple application, and it allows you to provide some sort of a time function that says, I'm not going to allow this to move on or allow this to not allow my building to warm up at all if I don't have some limitation. So I think it's a good strategy on here. So that's kind of one way. That's a basic priority system with a time limit. Let's take a look at the next diagram. Now, I am not a fan of doing these types of applications. It certainly can be done, and it's a little bit less expensive in some ways, but it may not be for the customer in the long run. And here's why. They make such a thing they make a typical system, and I'm going to highlight this in the diagram or in this system. They make what we're going to call a multi-zone relay center, and they have a priority override feature built into them. So they are going to include or contain, in those types of applications, they're going to include all of these relays, the time delay relay, the R2, 3, and 4 relays, R1 relay. They're going to include all of those things as well as this part of the circuit function. Now, when we look at that, what does it look like and how does that set up on here? So this is just one example. There are other ones, and they are just slightly different, whether you buy a Caleffi, a Taco, a Bell & Gossett, a Honeywell system. You have to just look at their specifics of that system. So we're going to take a look at this one in particular. Now, this particular application is, I'm going to show you the diagram of how this system looks like. So on the piping strategies, we have a boiler system that comes out of the boiler, and you'll notice a common header that's from C2. We've got C1 for the domestic water, C2, 3, 4, 5, and 6. So we have exactly 5 additional zone valves with these circulator check valves built into them, which would be needed in a system like that. Every one of the respective zones has its own thermostat. the domestic water tank thermostat is going to be we're going to use that as the priority zone thermostat. Now that priority zone thermostat will feed the demand directly from the domestic water tank heating demand input into that as a thermostat input up to the multi-zone relay panel. And that is how the piping strategy would kind of look like possibly. Now, let's take a look at the wiring wise and what this looks like. Wiring wise, what we're going to look at is on the wire. So this zone panel, this large zone panel system that we're describing here, we're going to have the 120 hot and neutral, which will go to its designated line 1 and neutral inputs on that. That will then in turn power the 120 to 24 volt zone, or I should say zone transformer system. So it's a system this transformer is going to be capable of handling the power consumption of any and all of these relays. So in other words, this relay 1, 2, 3, 4, 5, and 6. It can handle all of those. And so it'll take care of any of the low voltage side whatsoever. Now, the beauty of this one is this one will build into the diagram. It'll build right into here that if on this particular unit, they are using domestic hot water tank as Aquastat A1, they are deeming that as requiring to go to the T1 inputs. So they are providing simply nothing more than a contact closure to provide you a demand. And that's true of T2 through T6 as well. When that happens, what will happen in turn is the 24 volt that they're pulling from T1 is now going to be sent directly through, I'll make that a little bit smaller. That's now going to take the 120 or the 24 volts, run it through the A1 thermostat on a demand, send it down to T1. Now when it goes to T1, it'll take that circuit and complete the circuit path that powers up the Aquastat or powers up the relay, which would then in turn take that set of contacts and essentially close that relay, and of course that would then in turn power up C1, and this is of course the blue side of things is going to be my neutral side of things, is how that will be set up on here. Now when that happens, that's fantastic. That T1 or the C1 circulator is going to function. So my domestic water at this point right now is getting hot water going through this heat exchanger that's in this type of a domestic water system. Now, in this particular case, if the priority is set up, what it will then do is it would open up, this is the priority set of contact switching, let's say. It would then open that up, and it would then, of course, remove all 24 volt power from everything beyond here. So no voltage is going to get past that circuit to feed T2 to T3 to T4, 5, and 6. And so that's their priority. Now, if for some odd reason there is a problem with this zoning system, and there would likely be a timeout feature in this. Typically, they all would include something like that. Now, how does the boiler know that there is a demand? So let's hit that one up. So when C1 has a demand, based on a contact closure between T1 and T1, that was allowing us to energize that relay. This is contact is closed. Our zone circulator is powered C1. Immediately, what we are also doing is this set of contacts is going to close, sending 24 volts isolated directly to power this particular relay. Now this relay that's built into that is designated as to the boiler high limit control. So this right here is where on a typical hydronic system, what this would be doing is this would be going to what I would say is the heat demand input. is what that would end up being, heat demand input. So in the previous ones, this went to T and T. In other ones, it might have gone to T and TV or something like that. But it's some heat demand input for whatever that might have been for your obviously to that boiler system, whatever its control system has. Now, provided that if any one of these zone thermostats has a demand, it will wait until the timeout feature, or it'll wait until the aquaset says, oh, by the way, we're satisfied, which normally would happen, in a relatively short period of time, maybe 15 to 30 minutes. Once that happens, what we're going to do is remove the demand from the domestic water circuit. And when that happens, that means we take away power from there. Now, immediately, once any one of these other ones, so let's say that we only have T4 that has a demand. So that means this thermostat closes, we send power, complete the circuit on T4. That would, of course, powers up this particular set of, or that relay. That would then, of course, close the two contacts that are here. The one of them completes the circuit to keep the boiler demand relay circuit energized, which then, of course, will close that demand relay. And your X and X are then going to go to your heat demand input again. Of course, C4 has 120 delivered to it, so your pump is now going to be functioning. And this is going to be true of anywhere from C2 all the way to C6. If any one of those respective room thermostats has a demand, every one of those is going to function the same way. And they're all completely isolated in a nice zoning panel, which is fantastic for the sake of from troubleshooting standpoint. It makes the job much, much easier. So when I said earlier, in the long run, I think in a lot of ways a customer would be better. They would actually save money in the long run just purely from later on down the road from a troubleshooting standpoint. I can go to a zoning panel, I can see everything all brought right back to one spot, and I don't have to sift through a bunch of wire nuts trying to figure out what happened here and what happened there. So it's a much nicer setup on here. So here's another application, and I want to show you on this one. This is another application where we're going to use a priority zone pump system using zone valves. So the previous one, we looked at it using zone relays, which would of course be for a system that's going to be doing its zoning with all these circulator pumps. So whether it's C1 to C1, C2 all the way to C6. Moving on over to this next one here. So I have a zone valve system with a zoning panel, and we're going to use this figure down below, which is 721 and 722. Now 721, what I want to show you is just kind of a sample layout. And in this diagram, what we're doing is we're going to be looking at a typical modulating condensing type boiler application. And this modulating condensing boiler application that we're showing just as an example, doesn't have to be that, we are going to have a domestic water indirect hot water system that has its own thermostat that provides the demand. It's going to be using a circulator pump that's specific for that one. Now, why that's significant is that we're going to want to also, in order to do priority, we are also going to want to make sure that we are, during priority, we also have to think about, well, that means we need to disable the system pump if the priority pump is now being energized. And this should be handled by the wiring of how we do this system. I'm also showing a circuit that's identifying as a secondary pump. So this particular pump, on this, what we're calling the system pump, and the secondary pump would very much likely be kind of tied together to some extent. They don't have to be, but likely would be. And then, of course, if any one of those zones, whether it's zone 1, 2, 3, or 4, which is identified in this area, if any one of those has a demand, that means that we would definitely need the secondary pump operating and the system pump operating to depending on the water temp of the system. The priority pump would have to have been disabled already because that would likely be given priority. So that's one way to look at it. So let's look at the wiring and how this is done. So the beautiful thing about these systems is that we can go to the system and you'll notice that T-stat 2, 3, 4, 5, and 6 is, of course we don't use 6, but we're using 2, 3, 4, and 5. And on 2, 3, 4, and 5, you'll notice that they are giving you kind of what they identify as an R, a W, and they also have a common. So for us that are using these electronic thermostats that require a common to power these thermostats, this is an absolutely great feature. So we have now the ability to connect to a system. So many of the old ones did not have that, but many of the new ones do. And of course, the designated domestic hot water demand input is designated by this particular manufacturer of its zoning relay system as needing this to be on T-stat 1. Now, when we are doing this, that allows us to have some diagnostics. So we will know whether it's zone 2, 3, 4, or 5, or 1. If any one of these has a demand, we're going to see it by the LED lights that are on the right side of the panel. And it'll identify whether the T-stat has a demand and if the zone valve is actually completed the circuit. Now, these are on the 4 zone valves that are listed down below here. Every one of those zone valves is considered as a 4-wire system, and you'll notice that the zone 2 is going to be powering the motor of the zone valve. So when that gets powered and that valve goes to its full open position, that completes the circuit and it essentially will close the end switch. When the end switch is closed, that gives the input into the system that says, oh, by the way, this zone 1 had a demand. Now zone 2, that's zone 2. Zone 3 is the same way. They're going to have you'll have power going out to these, and that would deliver power to those zone valves. Typically, in most of these zoning panels, in most of the cases, you're going to have essentially, let's call it 24 volts hot, and you're going to have your common that's going to be on those 2 terminals. So as a technician, you're going to be looking for 24 volts between those 2 terminals. And then, of course, the end switch, if there is a contact closure by the end switch actually closing, that would then, of course, complete the circuit. That would then allow me to deliver the power right back into the board to say, hey, by the way, this actually did open up all the way. Now we can do some other things. When we do that, this particular application or boiler system, as I had mentioned earlier, we have a system pump that is now powered up from the zoning panel. That's going to be the system pump. Okay, so we'll call that system pump. This one is also allowing us to control a secondary pump, and specifically the way they are identifying this is in their diagram, they have what they call secondary pump, and they're calling system pump. So this one is one that if you are wiring up this particular system, you'd likely be looking at their wiring diagram and their strategy and their sequence to determine, is this the best way to set this one up? Now, that being said, this one also has a control to allow us to control the priority pump. The priority pump is deemed as the domestic hot water pump in this case. And of course, you can see the diagram up above to identify that. So we are controlling all 3 of the pumps that are in this system directly from the zoning panel, as well as controlling all of the respective zones that are on here. And this one also provides us a really nice place to tie in all of the, whether it's T1, T2, T3, T4, or T5. We have a place to land all of the wires from a troubleshooting standpoint. This is super easy to identify, the system. So it's really a nice, it's really the way to go when you're doing zoning systems. And then of course the T1 or T-stat 1 is your domestic water. That's a simple one. You know that one has to go there. Now here's the beauty of this. This one has a separate set of contacts that would allow the boiler system to know that, by the way, we have a domestic water heating demand, and we have in our boiler system, we have a separate set of contacts on using X and X as the space heating demand input. Now, the reason why that's important is this demand would be what we call non-reset. Now, so that means that where you would likely set up that if you need a domestic water demand, you would have a set point that the domestic or that the boiler would heat the water up to. So likely being non-reset, we may use an approximate temp for the domestic water, maybe somewhere between 160 to 180 degrees Fahrenheit as the limit. This is somewhat variable. You have to determine what is necessary for your system. I have used systems in the field where I have set up a max of 140 when I'm using a high efficiency boiler, and allows me to utilize some of the advantages of using the lower water temp. I can get a little bit more efficiency on this system. So it's really up to you. So regardless, this is independent of the outside air temp. It will always give you that temp. If there's a demand, it's going to try to achieve the 140, 160, 180, whatever that temp might be for your domestic water demand. Now, the space heating demand typically would be what we would usually be seeing is this would be identifying as a reset system. So that means if it's maybe 60 degrees Fahrenheit outside air temp, we would maybe shoot for a water temp that might be, maybe it ends up being 120 degrees, possibly. And if it's 0 degrees Fahrenheit outside, maybe we shoot for a temperature that's closer to maybe, 160 as an example, or 180. You have to figure that out based on the demands of that system. So there's systems where it could be 160, it could be 200 degrees. You have to figure out what is appropriate in here. So the one thing you have to remember is you want to keep that temp as low as you can to still be able to satisfy these requirements. And if you don't, you're not going to get the efficiency out of your system. So this is super important to recognize. Why do I need to have a separate set of contacts to tell my domestic water system, to tell my boiler that, oh, this is a demand for domestic water? And that's simply because we want it to be non-reset. And this one here is going to provide a contact closure to complete the circuit for your zones as far as 2 through 6. And that's essentially how that's set up on there. So this is, again, very nice system. And it provides you an awesome way to land your terminals. So in the one thing that I'm going to point out in this diagram here as well. So we have the ability to identify whether do we want priority, how do you want priority to work? Do you want priority on or do you want priority off? And we also have the ability to identify what do you want the pump to do during priority. So these zone panels make it very simple for you to control these systems, and it gives you a great place to clean up all of your wiring. All right, let's take a look at another one. We're going to do this time we'll do it as a very common, typical one zone pump type system is what we'll do. So we have a system pump that has zone 1 through zone 6. So we're going to use a bunch of those zones. Now when we do this, what we're going to be looking at is very similar to the previous diagram where we did it with a zone circulator, but this time we're going to change it around a little bit. So what we're going to do is we're still going to use the contact closure that's available when there is a demand. So if zone 2 through zone 6 have a demand, we are going to give this thing priority, which will then, of course, take care of that set of contacts. If T-stat1 has a demand because it's a domestic water demand, that will in turn send the 24 volts out to the zone valve. And if we want priority for that domestic water, which likely most people would do that, what we are going to do then is we're going to set priority, the switches, we're going to set these priorities to on. And when we do that, that's going to allow us to have control over the system. Now, that means priority would be on, and this particular one, by setting this as status during priority, that is going to allow us to say, that is actually the control for this particular system pump is what we are dealing with. So that's going to allow this pump to function. Remember, during priority, we cannot disable this pump. We have to keep the pump running is the way we have to do that. So now, during that priority, that means that this set of contacts will close, and it'll then in turn tell the boiler that, oh, by the way, we have a demand right there. Now, I don't know what the boiler manufacturer is going to give you for terminals as far as giving you the demand. You have to figure that out based on the control circuit to say which terminals or which wires, it could be colors of wires, are going to give me a domestic hot water heating demand. And I need to know that for the system. Very, very nice little system, very easy. If all of a sudden, you know what, we want to try it without priority, it's nothing more than setting the switch to the off position. So it's really a nice, clean, easy way to do these systems. So if you ever are involved in the field and wiring these types of applications for zone pumps and zone systems, I would strongly encourage using a zoning panel of some sort, whether it's by Caleffi or Taco or Bell and Gossett or Honeywell or whoever makes them. I would strongly encourage to utilize those types of systems. It sure makes for the troubleshooting and the diagnostics so much easier. Not to mention that it also gives additional features that are maybe available on some of these, such as pump exercising and ways to control it.